Hi, I'm Victoria Blanchard. I'm a computer engineering major, and my role for this project was to work on the remote connectivity and the graphical user interface in MATLAB.
My name is Kevin Holland. I'm an electrical engineering major, and my role for this project was to work on the RC car and do the project management.
My name is Lenny Martinez. I'm electrical engineering, and I'm doing the drone and the CAD design.
Hi, my name is Mohammed Walid, and my major is computer engineering. My role in this project was to work on SDR, which is software-defined radio.
Hello, my name is Pastor Lusant. I'm an electrical engineer major, and my role for the project was to work on the PCB.
The motivation behind this project is to increase network capacity. So as more devices are connected to the internet, we have more congested networks in your home. Like when your refrigerator, your phone, your computer are all connected to the internet. So now we need new techniques to process all these signals, and our testbed, which is open source and modular, allows researchers to take this type of research from the simulation realm to the emulation realm. Here we have the testbed controller all the way on the left, which is connected by Ethernet to the Wi-Fi router, and through there we can connect through all the nodes. As I said before, we have a very modular design, so we can go from node 1 to node n, and through here the nodes are connected to whatever test network it is we're trying to analyze.
From the testbed controller, we're able to wirelessly communicate with all of the nodes via SSH protocol using Python and Bash scripts. Also, through our graphical user interface, we're able to control the mobility node's movements and test parameters. For our test nodes, we have the main module, which is a software-defined radio module, which is going to have the battery pack, the Raspberry Pi, the PCB, and the USB hardware. This module could be either stationary or mobile. If it's mobile, the module can be placed on top of the drone or the RC car, which are both going to be controlled by the testbed controller.
Ethical consideration for this card. We want to make sure that our software is legally valid. For electrical safety, we want to make sure that the nodes have no possible crashing and damaging electronic, and we also want to make sure that we follow FCC regulation. And lastly, we want to test the PCB before ordering. Use our budget, which is separated into 5 categories to make it easier to follow: 1 for drone, 1 for SDR, and 1 for car, and 1 preliminary budget total, and 1 potential add-on. Overall, majority of our add-on was provided to us. We spent improvement. In this slide, you can see our PCB has improved over the semester. The first slide, the first PCB, you can see how we indicate the basic process with the switch, which indicate the node. And the second PCB, you can see how we clean up the path of the wire and we corrected the pin size hole. And the last PCB, you can see how we added the battery management on it for battery life indication.
The RC car node has seen upgrades throughout the project, including cleaning up the wiring, tucking things under and around the poles to avoid any tangles, upgrading the wheels to Mecanum wheels for better traction, and then making them rubber Mecanum wheels instead of plastic, and finally adding crossbars to act as axles to improve the stability as it drives.
For our machine learning portion, we use motion capture cameras and software to gather movement data of the RC car, and then in the future for the drone to analyze it for the accuracy of the movement to make sure that it's moving the distance that it is programmed to. Once we get that data, we uploaded it into MATLAB and used curve fitting software to do machine learning predictive curve fitting.
For validation test, we have a car and drone mobility test, and we have a drone battery test. For Raspberry Pi, we have a memory test. For SDR, we have a frequency and file size memory. For test control, we have a latency test, and for PCB identification test. Descriptions are given along with the measurement and the reason.
Our main function of our PCB is to show the battery life of the battery pack. You can see the flashing 4 indicating the battery life as a number between 0 and 9. The other LEDs indicate when a process is busy, but just to show the functionality, we connected it to these input switches, which will indicate what node it's in, just to show that these work.
This this video, we are running a batch script from the testbed controller by just one click that's starting the drone flying script, the car movement script, as well as 4 transmitting USRPs, 3 stationary nodes placed across the room, and 1 mobile node sitting on top of the RC car. Each SDR is transmitting a different frequency that are picked up in the waterfall plot on the receiver computer. One of our goals was to have another SDR module on top of the big drone so that we would be able to transmit and receive in a 3-dimensional space, but due to hardware problems, we were not able to fly the big drone. However, we are demonstrating that we can execute the mini drone's movement script at the same time as the car and the SDRs.
Here we are changing center frequency over real time. And for example, we are running 915 megahertz as our center frequency, and we are running as a sample rate of 1 megahertz. And our bandwidth is 10 megahertz. So you can see it on a waterfall display that our center frequency is changing from 915 megahertz to 916 megahertz over time.
We'd like to thank our CMNTM, Professor Rahim and Professor Zan, for all of their support, guidance, and resources needed for this project. We'd also like to thank Andrew Davis, Zach from the Technovator, Swaming Han, and Isham Dubey for all of their help.